Hello, this is John Harity at Mitsubishi Electric Automation, here to talk with you about Mitsubishi Electric's solution with PackML for machines within the packaging industry. Whether you're planning to implement PackML on an existing machine, a new machine, or simply interested in our general offering, my goal is to provide enough information so you can feel comfortable working with us to implement a fully compliant PackML solution. In order to better facilitate a discussion on our PackML solution, let's take a look at a demonstration machine that has been set up to fill cartons with a viscous material using synchronized cam profiles. Here you can see 5 servo axes being used to control servo motors over Mitsubishi Electric's fiber optic servo system controller network, SSCnet3. The entire machine is powered by Mitsubishi Electric's IQ platform technology. The first servo motor controls the loading station, which rotates cartons 90 degrees and places them onto the conveyor. For this particular demo, the loading axis only simulates this action. The conveyor servo axis then moves each carton to the filling station, where 2 servo motors are used to control the nozzle axis and the piston axis to simultaneously fill cartons with a viscous fluid, for example. Here again, this process is only being simulated. The control timing between the conveyor, nozzle, and piston servo axes is critical, however, in order to ensure accurate filling. Finally, we have the sealing station, where a servo motor is used to seal containers before they exit the line. As an additional option, a robot can be added to the end of the line to pick and place containers onto a pallet. Now, taking a closer look at the control equipment involved, you can see that we have a multi-CPU platform with a sequence controller and a motion controller at the heart of the system, coordinating movement between the 5 servo axes. Here we have the PLC, and here we have the motion controller. Additionally, we have an advanced MES interface IT module to aggregate data to an enterprise IT system, eliminating middleware and all gateway PCs for collecting and reporting data. We also have a digital input card, an output card, and miscellaneous additional modules for extra control if needed. And here we have 5 servo amplifiers controlling the 5 servo motors on the machine. We have 2 MRJ3W dual-axis servo amplifiers along with an MRJ3B safety amplifier. These allow for bookshelf mounting for an ultra-compact setup that will save space in an electric panel. With the use of a GT16 series graphic operation terminal, it is very easy to locally monitor and control a machine. For this particular demonstration, you can see that the machine is running in producing mode, and that we are in the execute state. If we pause the machine, you can see the mode change to the held state. The primary objective of PackML is to bring a common look and feel to the operation of all machines that are made up of discrete processes. The implementation of the guideline is based on and is consistent with the IEC 61131 set of standards and the ISA 88 Make-to-Pack program structure. Mitsubishi's implementation utilizes standardized function blocks, alarm and event handling methods, HMI screens, and a full set of pack tags. Down here we have several status displays, which are optional to display but definitely convenient for troubleshooting and reporting. You can see the total amount of time elapsed for the stopped, idle, aborted, and execute states, including the current time and cumulative times. Now, if I unpause the machine, you can see the state switch to the execute state once again. Switching over to the home screen, we can take this a step further to go behind the scenes with our PackML implementation. Within this particular demonstration screen, we can manually transition through the PackML states and modes, but only while the machine is not being operated. Here you can see that we are in the manual mode and that the machine is stopped. There's an option to test various faults within the PackML equipment modules, such as a guard door open for equipment module 0 and an e-stop for equipment module 1. Perhaps the more valuable resource from Mitsubishi, however, is that our solution comes complete with a template that can be used for a wide range of applications. Here, if we switch to a simulation of producing mode for explanation purposes, we can manually transition through the states within the state diagram. I can click on Reset and enter resetting mode. State complete brings me to idle, start brings me to starting, and state complete brings me to execute. At any time, I can click hold and I'll enter holding. State complete, I'm in the held state. Now if I abort the system, I enter aborting. State complete, I'm in aborted. Clear, I'm in clearing, and then state complete, and I'm back to the stop state. And now we can take a look inside the programming code for the programmable logic controller to see how Mitsubishi's PackML template applies for our filling demo, along with how it can apply for other machine types. This is Mitsubishi's latest programming environment, known as GXWorks 2, part of a complete automation programming package for industrial equipment. Over to the left in the navigation window, we can see that the structure of the program follows the S88 Make-to-Pack standards and practices. The machine is broken into unit machine level with 3 equipment modules, EM00, EM01, and EM02, which correspond to the loader, filler, and sealer stations. Each equipment module contains multiple control modules. For example, you can see that EM00 contains a control module CM00 for event control, CM01 for the GOT, and CM02 for the loader itself. Each control module handles the events in PackML command aggregation and summary. Furthermore, the unit machine levels aggregate the events and PackML commands from all the equipment modules to send the machine into its proper PackML modes and states. Combining a complete PackML solution with a filling machine provides several advantages and benefits for the end user, including maximized system uptime, flexibility to grow in the future, and reduced overall investment costs. PackML fits nicely with a fully synchronous, intermittent, or continuous filling machine, along with a variety of other applications, such as wrapping, labeling, and vertical form fill seal machines. And that concludes my introduction to Mitsubishi Electric's PackML implementation. Thanks a lot, and see you next time.